Today we will discuss about functional programming languages. This is the fifth unit of principles of programming language. Next, introduction to functional programming languages. The design of the imperative languages is based directly on the von Neumann architecture. Efficiency is the primary concern rather than the suitability of the languages for software development. The design of the functional languages is based on mathematical functions, a solid theoretical basis that is also closer to the user, but relatively unconcerned with the architecture of the machines on which programs will run. Lisp began as a pure functional language but soon acquired some important imperative features that increased its execution efficiency. The development of the typed functional programming languages, primarily machine learning, Haskell, OCaml, and F-hash has led to a significant expansion of the areas of computing in which functional languages are now used. Mathematical functions. A mathematical function is mapping of members of one set called the domain set to another set called the range set. Mapping one set to another set. First one is domain set, another set is range set. A mathematical function maps its parameters to a value or values rather than specifying a sequence of operations on values in memory to produce a value. Simple function definitions are often written as a function name followed by a list of parameters in parentheses, followed by the mapping expressions. For example, cube of x equal to x into x, where x is a real number. In this definition, the domain and range sets are the real numbers. The symbol is used to means is defined as the parameter x can represent any member of the domain set, but it is fixed to represent one specific element during evaluation of function expression. Fundamentals of functional programming languages. The objective of the design of a programming language is to mimic mathematical functions to the greatest extent possible. In an imperative language, the expression is evaluated and the result is stored in a memory location, which is represented as a variable in a program. A program in an assembly language often must also store the results of a partial evaluations of expressions. For example, to evaluate x plus y by a minus b, the value of x plus y is computed first. The value must then be stored while a minus b is evaluated. Management of variables is constant concern and source of complexity for imperative programming. In a functional programming language, variables are not necessary, as is the case in mathematics. Referential transparency. Referential transparency. In a programming fundamentals of functional programming language, the evaluation of a function always produces the same result given the same parameter. It makes the semantics of purely functional languages far similar than the semantics of the imperative languages. Applications of functional languages. It is used in mathematical computations. It is needed where concurrency or parallelism is required. Fact: WhatsApp needs only 50 engineers for its 900 M users because Erlang is used to implement its concurrency needs. Facebook uses Scale in its anti-spam system. Applications of programming language used for throwaway programs. Lisp is used for artificial intelligence. Why we use Lisp? Knowledge representation, machine learning, natural language processing, modeling of speech and vision. Scheme is used to teach introductory programming at some universities. Comparison of functional and imperative languages. Imperative languages. Efficient execution, complex semantics, complex syntax, concurrency is programmer designed. This is the imperative languages. Benefits. Functional languages. Simple semantics, simple syntax, inefficient execution. Programs can automatically be made concurrent. These are the comparison of functional and imperative languages. Logic programming language introduction. Logic programs are declarative rather than procedural, which means that only the specifications of desired results are stated rather than detailed procedures for producing them. Programs in logic programming languages are collection of facts and rules. Programming that uses a forms of symbolic logic as a programming language is often called logic programming, and languages based on symbolic logic are called logic programming languages or declarative languages. We have chosen to describe the logic programming language prologue because it is the only widely used logic language. A brief introduction to predicate calculus. A proposition can be thought of as a logical statement that may or may not be true. It consists of objects and the relationships among them. Symbolic logic can be used for the three basic needs of formal logic: to express propositions, to express the relationships between the propositions, and to describe how new propositions can be inferred from other propositions that are assumed to be true. Propositions. The objects in logic programming propositions are represented by a simple terms which are either constants or variables. A constant is a symbol that represents an object. A variable is a symbol that can represent different at different types. A simple propositions, which are called automatic propositions, consist of compound terms. A compound term is one element of a mathematical relation written in a form that has the appearance of mathematical function notation. A compound term is composed of two parts: a functor, which is the function symbol that names the relation, and an ordered list of parameters, which together represent an element of a relation. The two propositions man Jack like Bob stick, which state that Jack is a one tuple in the relation named man, and the Bob stick is a second tuple in relation named like. If we added the proposition man Fred to the two previous propositions. Then the relation man would have two distinct elements, Jack and Fred. All of the simple terms in these proportions, man, Jack, like Bob, and stick are constants.